Tēnā koutou, tēnā koutou, tēnā koutou katoa. Ko JR, tako ingoa, ko manukura rua au o te whare putai ao, ngā mihi nui kia koutou katoa. Hello everyone and welcome to the 2022 Gibbons Lecture Series. My name is JR and I'm the Deputy Dean in the Faculty of Science, and it's my absolute privilege to be here welcoming you and everyone who's tuning in a virtual sense to the Gibbons Lecture Series from 2022. This lecture series, of course, is in honour of Peter Gibbons, and I'd like to extend a very warm welcome to members of the Gibbons family and their friends who are joining us tonight. Peter was a member of the University of Auckland's Department of Computer Science from its earliest days in 1980 until his retirement in 2004. And that just brackets the time when I started doing computer science at the University of Auckland. I only did it at 100 level, but I have the suspicion that Peter taught me. He was the first external hire into the fledgling department, and he was a central figure in the department's development. And I think one of the things about Peter, when I was reading up on his virtues really, was the fact that he was very quick to pick up on the collaborative potential of the internet. And I think that he would have been really delighted to be here tonight for this year's theme, which is above and beyond cloud computing. And cloud computing, of course, offers an alternative to companies maintaining their own infrastructure, provides elasticity of resources along with promises around carbon dioxide emission reduction. I'm really interested in hearing more about that. And this year we have, in this series, we have 2 talks and 2 panel sessions, and they're going to run every Wednesday for 4 weeks. So I welcome you along to the first one, and I hope you join us for the subsequent ones. And I have to note that the series wouldn't be possible without the sponsorship of people like the IT Professionals of New Zealand, the School of Computer Science, the Auckland ICT Graduate School, the Strong AI Lab, and the Gibbons Lecture Fund. So thank you very much if you have popped some dosh into the pot to enable this. It's really appreciated. And tonight we welcome Associate Professor David Ayres from the University of Otago, who will describe the key technical advances that enabled the spectacular rise of cloud computing and how cloud technology looks set to evolve. And I'm super interested in that because I'm a geologist and I work in geological time. And I was just having a chat to David and marvelling at the punctuated equilibrium that I would describe as this incredible development of cloud computing. David completed his PhD in postdoctoral research in the Department of Computer Science and Technology at the University of Cambridge, and apparently was just down the corridor but listening very carefully to the folks that were really coming on board with the whole notion of cloud computing. And I know that David's got a lot of really excellent stories to tell, and I'm really looking forward to his talk tonight. So without further ado, welcome David.
This area to be streamed properly. So the audience participation, you're welcome to direct me back into the center if I appear to have drifted to one side. So first of all, I should say, tēnā koutou, tēnā koutou, tēnā koutou katoa. I am honored to be here to open this series. Having watched the series in the past, it's an absolute delight to be able to try to contribute to it myself. Cloud computing, it's been quite a ride. Everything as a service is what the cloud tries to offer and is thus the title of the talk that I'm giving tonight. It opens up this lecture series, which is talking above and beyond cloud computing. So without further ado, let's get into some of the material. My plan, okay, what's my cloudy background and what's the plan for what I want to do tonight? It goes as follows. First of all, I would really like to explain some of the key technical advances that built the cloud. I'd like you to take away an understanding of some of the really cool technology that sits there enabling cloud. I'm also very happy to talk more about it afterwards. I'm keen that I can highlight some of the challenges that are beginning to face cloud computing, because of course now the cloud is becoming so dominant, you end up opening up interesting challenges that come with that paradigm shift in how we do computing. I'm also keen to suggest some of the directions in which we're going to get some future cloud trajectories, but I would of course also draw your attention to the other lectures in this series, and particularly there's a lecture that's going to talk entirely about New Zealand and the cloud and the way that's going to work. That's one of the panel discussions that's coming up in a few weeks' time. The suitability for the plan. Why am I here? For a start, I've had a research interest in cloud, particularly because I came from a security background and found that there were interesting topics to examine within cloud security. But secondly, as has been mentioned, I was kind of just down the corridor from where some of the really key cloud technologies actually ended up starting. In terms of my involvement with the rise and flourishing of cloud computing, I was looking the other way. So I didn't really ride that particular ascendancy into greatness of computing paradigm, but I did end up having the honor of being able to talk to a number of the people that were key in that development, and I got to hear about at least some of the interesting problems that they were facing in terms of what they needed to do to make these technologies work. That's the wrong button, sorry. How do you start this? You press that. There we go. That's the correct button. 2001. Cast your mind back to that time. I've characterized this as being a time when, well, e-commerce was a term that people used as opposed to all commerce just being e-commerce. But it was a time where you had organizations embracing information technology, and by doing so, the client-server model, where you had client computers connecting to these server computers that were in machine rooms, were causing machine rooms to steadily fill up. Even in the residential college environment I was in at the time, you got this situation where you might want to do something like acquire a customer relationship management software package. But the people that gave you that particular infrastructure, the server that sat in your machine room that was the customer relationship management system, they didn't really want it sharing its database with the other server that you had. There was also a database server that was doing the database for the door access control system. They wanted to make sure that they could keep these things isolated and manageable. You know, if they had to come in and fix stuff, they didn't want all this noise and pollution of other concerns mixed into their computing environment. So what that ended up meaning was that as you wanted to isolate different software products, you ended up buying more hardware. But this was a particular problem because the hardware often ended up highly underutilized. So we had situations where you look at what was happening on the computers we had in the machine room. A lot of the computers would just be sitting at like 10% of their use. So their peak capacity of what they could do in terms of number crunching, they were nowhere near. The customer relationship management system had been specified to handle whatever spikes in load on customer relationship management systems look like, maybe alumni drives or something like that. Most of the time, you weren't running an alumni drive, even if the development office probably wanted to. And it meant that that server was just sitting there close to idle. Now, what's the problem with that? The problem with that is that when those computers of the day were sitting close to idle, they weren't doing any useful data crunching, they're still using a lot of electricity. And I've kind of approximated the numbers-ish. These are not completely precise because, of course, you'd have to say what type of server was I talking about. But I've tried to rewind the clock back to the day and give you a bit of a sketch of what machines might have been like at that time. Power-wise, the base load of your typical server machines was about 200 watts. That means if it was on and doing nothing, it was going to be drawing about 200 watts of power. If you ramped up the CPU to be at 100%, so it was busy as it could possibly be, which typically you don't do anyway, because it typically means things start getting a little bit unstable and a bit risky in terms of the software kind of actually working properly. Even if you did that, you might only be adding an extra 100 watts worth of load. So you can see that if you start multiplying the number of computers that you have in your machine room, this is really not good. You're wasting a lot of resources. But moreover, you're just wasting a lot of equipment anyway, because all of those servers could do more work. They're just not really being given a useful kind of job to do. So that was the situation that we were kind of facing. We then moved forward to where I happened to be at the time. I had the privilege of being doing my PhD at the University of Cambridge. The very time that I arrived, I ended up at a dinner where they were welcoming new people into the PhD program, which I was feeling rather nervous about. I ended up being sat next to a fellow by the name of Ian Pratt, who talks more than I do. That was a refreshing change to begin with. But the other thing which was wonderful about Ian was he was clearly brilliant, but he was extremely inclusive. So he talked the whole night to me about everything that he'd been doing in that research space. And the thing which I took away was I felt that it was actually achievable. I mean, I couldn't do it without a huge amount of work, but you could join Ian, and with him, you could actually get these remarkable things done. He was so inclusive. It was a really, really positive experience. Am I doing that? I'm not sure if I'm doing that. I'm just gonna, maybe I'm walking too close to that side, so I'm gonna go back into the middle and hope that it stays still. To quote from one of the papers that was published from Ian's group, because Ian was heading the systems research group at the University of Cambridge Computer Laboratory, as it was called at the time, they'd been working on this theme of resource control inside operating systems. And one of the things which they were doing was building pretty solid prototypes. So they weren't kind of making vaporware that kind of begins to bit rot the instant that you take the funding away or the student leaves. They were trying to build these quite solid systems to prove their ideas. What that meant was all their PhD students were running over by about like 1.5 times because they spent so much time writing code. So it's not necessarily all good for everyone, but it did mean they had some very solid things to base their work on. The vision really was interesting when you look now at what the cloud is. From their Hot OS, which is at one of the conferences, 1999 paper, if you don't mind me reading that quote, they say, "We propose a system that can execute code supplied by an untrusted user, yet can charge this user for all the resources that they consume by the computation." So this was the Xeno server vision as it was seen by Ian, this idea that you could safely run untrusted code, but you could account for that code's use, but you needed some way to actually make this work, because essentially you're running anything, like the operating system that you're running from these users could be any particular piece of software. So you need something which can kind of allow you to do that safely. The typical way you do this, and this is the sort of first key cloud technology, is this notion of virtualization. You want to virtualize the untrusted operating system to make it become something which you can manage for this kind of resource accounting and isolation in terms of security. So this is the first key technology. What you want to do is take the physical, and the figure on the right-hand side begins by showing 2 physical servers that might have sat in the machine room. They're sitting on, I don't know why the hardware's purple. I'm slightly colorblind, so I kind of just like use that as my kind of get out card for all color choices. The hardware's purple. You've got 2 computers sitting next to each other with their stacks where the hardware is sitting underneath the operating system. Could be Linux, could be Windows on those 2 different computers. And then you've got stuff running over the top. These are server applications, a web server, something like that running over the top. What you want to do is take that physical infrastructure with those 2 different physical computers and you want to virtualize them. That's where you take the 2 different concerns, the 2 operating systems, which could have, as I said, been one being Linux, one being Windows, and you want to run them over the same hardware. You're consolidating those different operating systems from those different physical servers to run over one physical server. So the idea is that you can then run this untrusted code that is being presented to the Xeno servers, and you can run it in these virtual machines that I've highlighted by the grey boxes there. I do understand the colour grey. How do you make this work? For security purposes, you need to slip in this layer of protection. And that layer of protection is called a hypervisor. It's not the only thing it's called, but I'll call it a hypervisor, and I'm happy to talk about other definitions later. You slip that above the hardware and underneath the virtual machines. And it can switch the resources of the physical computer so that you can then have all of these different virtual machines run over the top. But one of the interesting things to me here is that virtualization itself is not a new idea. It's actually been around for a long time. IBM was doing this in the 1960s. As a general rule that I tell my students, if you want to look for the next big thing that's going to happen in computing, go back 30 years and look at what IBM was doing and then give it a new name. And that's possibly a way of discovering the next big thing in computing. The environment changes slightly to mean that you've got a new accessibility of possibilities because our parts of the environment are different. But so you've had since the 1960s IBM being able to do this work. You had VMware as a company that was doing innovative work on PC hardware, even in sort of 1999. But the problem is these workloads weren't quite right. First of all, the VMware workload wasn't really quite trying to do the security isolation. It was more allowing you to be able to kind of do tech support, freeze and freeze and restore the state of virtual machines if you needed to like test a software product on Windows 95 and Windows 98 and Windows Millennium Edition, whatever that was, Windows XP. You had all these different systems you might want to test your software on. Rather than having to have physical computers of all those different types, you could use VMware to more conveniently run virtual machines on one platform. But we'll see on the next slide why that wasn't quite good enough for what we needed for xenoservers. The price tags, though, that was a problem for research because the price tags were quite large. These technologies didn't come cheaply. So what did the research group in Cambridge decide to do? They decided they were going to build their own. And it turns out that they were in a very lucky position that had a whole series of PhDs that contributed useful components that actually sat together. So they were complementary in a really true sense. So the sum was really a massive amount greater than the sum of its individual parts. The paper that I'm showing here on the right-hand side was the seminal work that came from their stuff, Zen and the Art of Virtualization. And what's key here is that the paper title doesn't suggest that they invented virtualization, but more that they fine-tuned it. How? Well, we'll have a look. So Cambridge's system was called Zen, and really, I think, was one of the key things that kicked off the development of cloud computing. The point I'll talk about is the performance comparison. So I've drawn out one particular figure from the paper from 2003. Now what this shows with these collections of bars is a whole series of different experiments. The thing on the left-hand side is not very interesting because it's always at 1.0. It's normalized, it's Linux, just running unmodified. So that's a physical computer with no virtualization doing whatever the workload is. The right-hand side, the rightmost bars in each of those sets, the light grey colour is user mode Linux, which was expected to be slow, even though it's a handy thing to have around. The third column across, and apologies for the non-linear order here, but hopefully we're all okay with that, the not totally light grey, but slightly less light grey bars that are third from the left or second from the right, in each one of those, that is VMware. And the other one, which I haven't explained, the second from the left, is Zen. What you see is the performance comparison here showed that VMware Workstation, which was an expensive closed source commercial piece of software, you have in the point that I've highlighted by this arrow, an impact on that particular test that I've highlighted with those arrows. What that graph is showing is that VMware is sort of running that workload in the order of 10 times slower than running on a physical computer. So if you take that workload and you run it on VMware, then rather than getting full physical computer speed, you get 1/10 of that speed. In the same test, Zen is coming in at 95% of the speed. So you're taking a 5% performance hit by having virtualization. Now, this wasn't something which they were really expecting to discover. The Cambridge team were just putting their ideas together and trying to build a thing which is an open source system. But this is the point, was that Zen ended up being free, Libre in the sense that it didn't have restrictions on its code, well, it was GPL'd, but otherwise it was shared in the same way as the Linux code base. It was open source and it was much, much faster. You see, the worst performance that Zen ever gets is still above 90% speed here. So this is really kind of crucial. Somewhere else in the world at that time, we have Amazon beavering away. They were running a very successful bookstore and selling other goods in the e-commerce world as it was. And then realized that actually their expertise in being able to kind of sell books and run these online stores wasn't something that had to be particular to Amazon. Why shouldn't they try to resell their ability to do e-commerce websites to other organizations, like Target in the US? And in fact, that was indeed one of their clients. So the idea was that you could essentially take the Amazonness out of the Amazon e-commerce platform and use it for other e-commerce platforms. So in this case, that's what started leading to this system, Amazon Web Services. Now, nowadays, if you say AWS or Amazon Web Services, people think of that being a cloud provider. But of course, the word cloud is not in that term, because indeed it came along before the cloud. It first appeared as a sort of blog post, which was Amazon describing how they were kind of trying to turn what they were doing into this sort of system of decoupled web services, rather than having everything tightly couple the Amazonness into the e-commerce-ness. So they kind of pulled those things apart. And they launched these services around 2006 to the greater internet, or the rest of the internet. I'm not sure if it's greater or not, from Amazon's perspective. The simple storage service, S3, came out in March 2006, and then quickly followed, we had the Elastic Compute Cloud, EC2, in August 2006, very, very soon after. Now, the key point is that EC2, the Elastic Compute Cloud, is the first of these examples at scale where you could have pay-as-you-go computing as a service. So we're beginning to get to the as-a-service theme of this talk. You didn't need to have physical computers anymore. You could simply hire the ability to do computing on Amazon's infrastructure. But the thing which was really cool about this was that it used Xen, the Cambridge technology, to actually make this work. So the original launch used Xen as the mechanism in EC2 to host Linux virtual machines. Now, one set of people who thought this was kind of cool, but also rather surprising, were the Cambridge people, who had absolutely no idea that Amazon were going to use Xen to actually launch the cloud. But you've got to say they released it openly and the price was right. Amazon liked the price, and Amazon had a team of good engineers, so they ran with it. And indeed, that's where the cloud came from. But it wasn't all problematic for the Cambridge mob. And checking back in on the resource efficiency, I wanted to reality check another part of what was developing in this picture. Xen had another really useful impact. Not everybody was ready to move to the cloud straight away. It's still the case that not everyone is going to move everything to the cloud even today. But Xen had another major impact, which was the efficiency of local virtualization. So virtualization you'd use in your own machine room, even if you had no intention of shifting your workloads to the cloud. They formed a company, ClientServers Incorporated, that developed as a service organization around the open source Xen system and essentially positioned itself as a VMware competitor. They weren't trying to be commercially competitive specifically, but they had this thing that was kind of good, so they may as well use it. Of course, VMware didn't have to worry about Xen secrets because there were none, because it was open source anyway, so VMware were welcome to look at what Xen had done and incorporate those technologies themselves. That's fine, that's what open source is all about. And that's indeed what happened. So the useful point was we got the viability of cheap, high efficiency virtualization being proven, that you didn't have to worry about that overhead. You could take all of those multiple computers you were running in your machine room and crunch them down to a smaller number of servers. Now in this case, I've depicted, and it's not drawn to scale, it's only SVG clip art anyway, I've drawn a whole bunch of servers that have gone to a smaller number of servers. And the point here is that you don't consolidate everything down to one server, because that server might literally catch on fire, in which case it's kind of inconvenient if you lose everything that server was doing for a period of time. So normally you'll have at least two servers, so that one can literally catch on fire, and the other one can take over while you put out the fire and replace the burnt computer and get another one back in there to take its job again. But the consolidation ratios were the point. It was not uncommon to see aggregation factors of 12 to 1. So 12 physical computers could be run on one physical computer, a massive power saving, which we've held forward since that time. So that's a kind of example of a very useful carry-on that happened that wasn't in the cloud, but was based on that cloud technology. So let's zoom through what then happened with an as-a-service. I've painted the point that we've got to having computing as a service. We'll kind of run up the stack of software to sort of see where the as-a-services get us, and then talk about the other points that I want to cover tonight. What I've shown on the right is a figure that will stay on for the next couple of slides, so you can consult it if you so choose over time. I'm trying to indicate a couple of different points here. I'm not sure if the colors are exactly the same. They're slightly similar to the previous one, the previous diagram that I showed here. What I'm showing you is the way that you've got different layers of software in a software stack that you might run. And here I'm kind of showing how you can slice off different amounts of concern, different abstraction levels that you might choose to use as a client of cloud computing. So one of the key points about the on-demand purchase of access to virtual machines, which is something which I kind of understand, at least in theory, is the whole commerce thing. So I've kind of summarized most of what I know about commerce in that second bullet point. It's not entirely true. I'm sure all academics will need MBA soon within the current university system trends. But the point that I'm saying here that's important is with IT, we have now capital expenditure where you used to have to buy machines, buy space for machine rooms, buy air conditioners, and you didn't even know exactly how many you needed because you weren't sure how many clients you had. All that stuff stops being capital expenditure and starts being operating expenditure. And it doesn't even necessarily matter if it's slightly more expensive as operating expenditure than it was as CapEx, because the advantage is it scales really nicely. So if you say, every one of my clients, I'm going to budget this amount of operating expenditure for my cloud costs, then if you get 200 more clients, You just pay 200 times more cloud cost, and that's totally fine. You don't need to think, whoa, my machine room's full, I need to find another building, which is a problem that you have if you're dealing with physical servers. So it's really kind of transformative for organizations that need to work with these sorts of costs. But the other point is elasticity. Not only do you need to, you can change that scale, you can change the scale really quickly. So if someone kind of comes along and says, oh, there's a load spike now, we have hundreds of users arriving right now, you can suddenly provision a lot more servers and essentially be a much bigger organization briefly. For the cloud providers, you also get economies of scale. They can build really, really efficient data centers in terms of the cooling and the energy and all the type of parts that they need to handle on their side as well. But if you're a client, you still have to manage the operating system and software updates for that, which happen all the time because operating systems are terribly insecure and all the software over the top. What if you just wanted a really big database? And like, sure, it might need 10 machines or 100 machines. You don't care. You just want to pay for that big database. That's where we get platform as a service. So you change the level of abstraction to be higher up the software stack. Now, instead of managing servers, you're managing services. I'd never say the words like that except for that illustrative purpose. But so the point is you stop having to think about the computer servers and start being able to say, I just want a big database. A quiet time, your database might be running on 2 virtual machines. A busy time, it's running on 100. But you don't have to care because the clients can ignore the virtual machines. You just pay in terms of database accesses, not in terms of having to compute virtual machine hours that you need to rent or something like that. However, you still need to manage the software. What if you just want to have email in a web browser? You don't want to have to think about any of those other concerns like how big your database is. That's where we zoom up to software as a service, which is the sort of topmost level of the big 3 as a service monikers that are applied. That's where your local computer now just becomes this kind of window onto the cloud. So it's showing you cloud software. Typical examples would be productivity suites, Google Workspace. They keep changing the name. I think it's currently called Google Workspace. Office 365, which is missing some of the year. I don't quite get that either. And iCloud, which no one uses. So that's kind of a collection of all of your big productivity. Well, I use it, which of course has caused all the technical problems this evening, which is why I'm waving my phone around. Anyway, so that's an example of the 3 big kind of providers giving you these productivity software. You just see that as a window from your computer. Okay, that's the authoritative data is now off in the cloud. But it's much more than a fancy website. Like rather than just being some kind of thing that you can access through the web, it really is the point that it feels like fully featured software. Like sure, you might use a web browser, but it doesn't feel any less effective than running a fully functional piece of software on your own local computer. That's partly because browsers have got ridiculously powerful and include a huge amount of technology within them. And it also doesn't mean that you can't do a really bad job of this, but that's a separate point. The other thing which I find characterizes software as a service is often you get another player in the picture. So you often will get the tenant of the software as a service might be the organization that you work for as an employee, and then they configure the service that you actually use. So at the University of Otago, we've gone mostly Microsoft. We have Office 365, so like the email system there, we have the mail admins at the university. They work with Microsoft to figure out how to customize what we then see as staff members at the University of Otago of our email when it delivers it, etc. So that's the kind of software as a service sell. The interesting point now is that increasingly we're getting the ability to integrate and customize software, even though none of it's running on your computer. So that's been something where we've seen great developments, is the ability to link together these different services in the cloud. So all of this is happening remote from where you actually are. And that gives us this situation. We get to everything as a service. I'm not quite done. I've still got a bit more to talk about, but that is nonetheless the title of the talk. So we've kind of reached the pinnacle in terms of the upward journey towards getting to everything as a service. They then gave an acronym to it, which doesn't quite work in terms of the spelling and all. It's a bit odd, but that's fine. We'll run with it. XaaS, or sometimes Star AAS, is talking about this umbrella term of everything being in the cloud. And so what you end up now is a whole series of offerings like security as a service, networks as a service, storage as a service, desktops, databases, whatever, as a service. Technically, most of these, I would say, are actually just a specific type of one of the 3 layers I'd already talked about before, but they're just sort of differentiated for a particular client offering. But what this now means is that as a business owner, not that I've ever been one, I've always been in the academic system, but let's assume that I understood how to be a business owner, I could run a small business from a cafe. All the key business things that I need can be accessed from a web browser, sitting in the cafe. Let's assume the Wi-Fi stays up. business goes broke due to Wi-Fi failing in cafe. It's a cafe with good Wi-Fi. The point here is you've got customer relationship management systems, issue management, accounting, payments, gateways, your document management, a way to communicate, and a coffee. All of that in front of you in the convenience of this kind of cafe environment. No data centers, no fixed costs to run large, big chunks of iron to make your system work. And everything scales up and down as you need it to, depending on what you're currently doing. Nice. Challenges. Now, admittedly, this is like a couple of snippets that I've taken. I have a little file where I keep when software fails, because I find failing software really interesting. When software fails, I kind of take little sort of clips of it. And I thought for tonight it worked because I could give you a clip of all of the major cloud providers losing my data at some time. Now, admittedly, I have a knack for breaking software whenever I touch it. I'm not trying to, but I just seem to be able to automatically. But here's Google losing data, Microsoft losing data, iCloud losing data, someone just doing web wrong. And the dialog box on the top is actually not relevant to the cloud, but I just thought it was such an awesome example of programming ending up accidentally putting an internal message to the user. Shh, bad news coming. It's like, indeed. Cybersecurity, it's a challenge. Now, security problems have been growing both with and orthogonal to the cloud. Early cloud adoption was often blocked just outright by security concerns. So your organization would say, absolutely no way are we going to be shifting that database into the cloud. You've got to be kidding. Like, it's got to stay on premises. Like, that's absolutely not going to the cloud. A few years later, you now get to the situation where the organizations are like, there's absolutely no way that we're going to try to safely store that data on site. It's absolutely going to the cloud. That's not necessarily the case for everything, but it has been a trend. The main constant here is that cybersecurity is a problem, but the cloud plays a role in what sorts of ways we can both protect against it and other things we still need to fix. Originally, data safety was being equated with locality. If you had the data close to you, it was safe. But the problem with that is that the different sorts of threats and attacks evolved. We have much, much more ransomware and malware that attacks on-site systems. So that was kind of a situation where now actually the cloud providers have economies of scale in terms of security. Why? How? Well, for a start, they have global visibility. If people are going to start attacking things, they see that coming from anywhere because they've got their own network infrastructure that connects the globe. One of the downsides is that it does mean that all the defenses that you actually have are very likely to be homogeneous because you're all using the same cloud thing. So when a cloud fundamental security problem happens, there is much scrambling because suddenly the cloud provider has to fix everything at once. That has happened with examples for the Intel CPU bugs, like the things that caused Spectre and Meltdown. Those meant that there would have been a lot of Amazon engineers and all the other big cloud providers losing quite a lot of sleep because they had to patch every single one of their servers. And again, the number of servers that they run are just crazy numbers. So we don't know for sure because it's a commercial secret, but we're definitely in the millions. And if you think of what it means to have millions of servers, that's just crazy. But nonetheless, it is an interesting situation if you're a security person there. Another challenge is that there are just so many different stakeholders involved. So the cloud technology, in some senses, may sometimes actually even be the easy part compared to the coordination that has to occur between all these different participants. And this has become more clear as you run this kind of business for longer and you start seeing more of the wrinkles that are going to happen when commerce depends on this as infrastructure. But so the list I've shown here is not complete, but it's even just a start. You've got cloud providers, you've got cloud customers, you've got the end users like most of us, you've got regulators, legislators, you've got law enforcement playing a part as well. You need to coordinate all those interactions. The cloud data processing is by its nature like dynamic, really fast outsourcing. So sort of the analogy is like if you're trying to build a house and you discover that the service contract for putting in a brick wall involved every brick being dynamically priced from any builder anywhere on the planet, you can see how that would get rather complicated to actually figure out what's going on. It's easy to explain what you're doing with the dynamic market, but it might be hard to actually build the brick wall in a way where you know who's responsible for what. So how do you protect against data despite all of its international transfer? And how do you even track what's going on in terms of how the data is changing hands? So a call out to the European Union, as is not uncommon from people who have left the UK to come to New Zealand and now watch the UK leaving the EU. We have to kind of mention all the good things the EU continues to do. General data protection regulation, that is one for us as citizens. GDPR has done a huge amount in terms of protecting the privacy, the protection of your personal data. Now, of course, New Zealand is not in the EU, but the advantage of the EU being so big is that if they do something like that, then we'll also receive the notifications we all received in 2018 saying we're going to change our terms and conditions because of the GDPR, blah, blah, blah. The world isn't worth segregating between the EU and everywhere else. So we got the benefits of the kind of personal data privacy that's come from that sort of EU initiative. And New Zealand has strengthened that, so absolutely the New Zealand government has played its part well there too. But another challenge, national data sovereignty. So data processing is often outsourced overseas. Now, if that starts including your citizens' personal information or healthcare records or things like that, how do you start protecting what's actually nationally significant? And that's the data sovereignty question. Maori data sovereignty is a particular aspect of that raises some interesting questions, that many of which will probably be discussed in the panel that's in this lecture series on the 25th of May, which of course I wrote a long time ago. That's actually otherwise known as next week now. So next week. But for now, I think that we've got the case that data sovereignty often assumes this idea that local equals safe. And I think that we're going to have to probably evolve from that over time, just to feed some discussion to next week before it's even happened. No nation can avoid technology supply chain attacks. And that's been one of the recent things we've started to see happening. And everyone is intermeshed in terms of supply chain dynamics right now. China's recently again said they want to clear out Western equipment from government offices and have Chinese-made equipment. It's just not that easy. That's been tried multiple times. China can't do it. The West can't clear the Chinese stuff out necessarily. Everything is intertwined. No country is self-sufficient in terms of computing or data either. If you close down the walls and don't allow anyone in for maintaining your data infrastructure, you're going to discover you've got some real problems when things start breaking, because we simply don't have engineers that can do all the things you need to do to fix all of that equipment. So in future, I think we're going to likely need specific multinational technical protections that are agreed as sort of treaties between different countries. Sounds sort of like the EU. I'm going on about that again. Not quite. But say for us in New Zealand, we might pick Australia, maybe. I don't know. Maybe that depends on what happens this weekend. Another challenge you're getting here is on the other side, the provider side, concentrated commercial control. Originally, the internet and the web were highly resilient organisationally. They could handle failures of infrastructure and keep working. But commercial pressures have driven economies of scale. What you now have is the core cloud is a very small number of very large providers. Okay, and that doesn't matter whether or not you include all the Chinese providers or not. You're still talking about a very, very small number of very, very big organisations. Now, we're seeing some potential regulation on the social media horizon. Some governments are unhappy at the degree of social media companies scale. Some other governments are quite happy with it, but it depends which governments you're talking about. This also relates to cloud law. It's difficult to have legal protections work when these cloud providers are international and of themselves nation-scale organisations. They are that large. But again, the EU is helping us out. Recently, we've had two areas of great progress. The Digital Services Act, which is focusing more on misinformation in social media campaigns and controlling that kind of the information on social media platforms, but also the Digital Markets Act. There's the term given to these very large providers of being the gatekeepers. And so the Digital Markets Act is trying to tackle those gatekeepers for EU companies, meaning that if you want to do something innovative in the cloud space, you don't have to first magically become the scale of Amazon before you can even start kind of working in that space. So again, that's going to be interesting to see how that develops. There are different, they're not actually regulations yet, they're still in formation, but it will be interesting to see where they go. So on to the future. Now, again, there's a panel discussion, as I mentioned, about the New Zealand and what's going to happen in terms of the cloud future, so I won't be taking their thunder. But what I'm going to try to illustrate here is the trajectory I think cloud's going to take. Computing on our data, and I mean very broadly, like sort of most of the computing happening on most of our data. I'm not trying to talk about every specific instance. It's shifted where it's happened over time. So in the start, you had this big iron up in the top left, your mainframes, your gigantic business computers that could crunch numbers, but you had to bring all the records to that centralized location. We then had this proliferation heading down the right-hand side to the decentralized part of the axis here, where you have personal computers. And for a while, you carried the data around on floppy disks or CDs or zip disks and other exotic forms of media that probably don't work anymore, if you can find a drive to even try them out. I love that stuff, but anyway, that's another topic. So the PCs kind of started having all of the data being carried around by people using sneakernet to kind of copy the data from location to location. Now over time, we've kind of now shifted back to something which is much more like cloud computing. It's centralized. we have most of the data now working there. Even when we have decentralized computing, like people with smartphones, which is pretty much everyone, a lot of the things we do are still cloud-backed. Okay, so the cloud is an important part. Sure, the smartphone can do a lot by itself, but the general data crunching is likely to involve cloud interactions. So I would say the past might predict the future. You could say that I'm extrapolating from 2 data points. Anyway, I think we've already started seeing some of the trends that kind of indicate that this is actually what's happening. For a start, we're beginning to see things like decentralization with AI and machine learning happening in mobile phones. That's a very sensible and sane technological development to support privacy, because it means you can do useful things, but on the device. We've also seen Web3 and decentralized finance, which is, I'm sure it's got goals as well. And that's also decentralized, and we'll see where that stabilizes in future. Shifting out from the cloud, getting closer to the users is going to become important. And again, there's another talk in the series this year talking about how we shouldn't assume that everyone has access to fiber optic broadband. Actually, access to the internet is not global by any means. But in places where you are able to get 5G for your super fast connectivity to your smartphones, it's not particularly useful if all you get is really high fidelity spinners telling you that you're waiting for a cloud server. So what you want to start doing is creating a local loop of computation. And you can do that by dropping computing down at the cell phone tower. This extends the cloud, but it still depends very heavily on the cloud. This is very much already happening. Right now, there's a lot of data working in this way with content delivery networks, which are a very common way to push data out towards users. The Internet of Things, and I've just sort of taken a Creative Commons licensed picture of a Raspberry Pi enhanced toaster in the theme of the sort of IoT toaster. The Internet of Things I've characterized here, and apologies for any Internet of Things researchers, as sort of adding software, storage, and networking to all electronics. That's sort of the Internet of Things broadly speaking. Today, I would say it's still the case that Internet of Things devices are fleets that are managed through the cloud, because that's the easiest way to make this work. It was discovered rapidly that configuring all of the devices independently is actually really quite painful, so it's useful if they can call back to the cloud and have their configuration managed that way. That also means that if your toaster breaks, that you don't lose the data of your perfectly toasted bagel settings. You can get a new toaster and the cloud will download your bagel settings so you can continue in your toasted toroidal nirvana. In future though, what we need to do in terms of making this actually much more functional is make it secure and private and interoperable, of which those are huge failings at the moment, resilient and power efficient. Because just because we can move things away from needing really, really big chunky data centers like the ones that I've shown here on the left, that doesn't mean that we should be just using energy because we can. We should be thinking about why we're using the energy. I've sort of sketched this as a just sort of abstract example. It's a little bit down the smart cities line, which is kind of more of an Internet of Things thing, but I'm borrowing it here. I like the idea of thinking that we'll get to a point of something more like ambient computing, where we have nomadic code and data. The devices become irrelevant, except for the input and the output that they perform relative to where they are in the environment. What we'll need for that to work is have ways of making collaborative provision do so safely and with reliable computing and data. Right now, though, we simply cannot commit to this given the current state of security and regulation in the technology stacks we're dealing with, which is not ready. We can't sensibly do this yet. I want to leave you on a different as-a-service that I think personally is possibly one of the paradigm shifts that could be huge. Or I could just be wrong, but that's okay, we'll find out later. Function as a service, which is also known as serverless. I try to use the term function as a service because it does use servers, which means it's serverless is a slightly strange and misleading term. Function as a service, the idea is that you take the actual computations you want to perform and you push them into the cloud. A little bit like the line of my ambient vision here. They could float to where they need to go to do the work they need to do. Most software is imperative at the moment. You instruct the computer step by step. So the Python listing up here, I'm supposed to talk for 40 minutes. We get 10 minutes of questions. That's the total time for the talk. It'll print the total. Now, if this turns out to be wrong when I start running overtime in about 10 seconds, you need to change that number, and then you need to rerun that program so that it goes and takes the variables and recomputes the total and figures out how long I actually ended up talking for. Now, that's a bit inconvenient compared to the other type of programming that I think works really nicely, which is data flow programming. And most people have experienced this because many people have used spreadsheets. Spreadsheets are a form of doing data flow programming. And there, the data recomputes the outputs when the inputs change. And we're starting to see forms of that that can actually operate at internet scale and can distribute in a very flexible way. Function as a service is kind of heading in that direction. And that's great for at least two reasons. You can migrate the functions towards where the data is. So when the data changes, you're close to those functions and you can recompute effectively or even recompute redundantly if you need to. But you can also migrate the functions to where you've got energy. Because it turns out that shipping energy around is actually really expensive. Shipping computing and data around is comparatively cheap. So it's good to have a model where you can actually follow renewable energy sources or spikes of energy. The thing which I really like about this is that function as a service is starting to appear both in the cloud and already at the edge as well, which to me seems like a kind of sign that we might be going down a paradigm shift. So some takeaway points. I think that the cloud is it's provided new abstractions that are definitely here to stay. The data and computing locality is very likely to change in future. Jurisdiction and regulation and cloud law and all of that's going to need a big boost for us to figure out where we need to stand and where we need to go. We've really got to fix security. There you go, call that to you, Giovanni. Not specifically, it's not entirely your problem, but I mean, security is important for research. We have to look at security and privacy and the things connected with that, and with that, come to an agreement of what we mean by sovereignty and how we choose to be comfortable with that. I think we're going to shift to decentralize. Hopefully we won't go techno-libertarian. Let's see where that ends up. Finally, I think we need to look at reducing power consumption. A lot of noise has been made about efficiency, which is great. It's excellent to have efficient data centers and efficient computers, but we also need to think about purpose. There are clearly some places in the world right now where people are doing a vast amount of number crunching on data that is not worth the energy that's spent on that number crunching. So I think collectively, we need to come to some agreement as to what is a reasonable purpose on which to do computing and put that into the equation of considering power consumption. Thank you.
Okay, so we've now got 10 minutes for questions, as you all know. So what questions do you have today?
If you don't ask questions, I'll just keep talking on autopilot. But that's a really great question.
Can you repeat it?
You can correct me if I've got your... Because you've suddenly got these legal considerations and things that might mean the locality of where you work becomes a problem. Is that going to lead to move away from the centralized cloud? I'd say sort of probably yes and no, and it depends. And examples that spring to mind, you look at a place like, Dropbox have already done this in the sense that they ended up drawing different parts of their data into different countries' data centers because of this very fact. For them, it's like once you get to that scale, you can simplify your operations by just going, if we EU bit and the not EU bit. And a lot of the really big companies have a division like that. Apparently Google has a division between data that can be requested to be deleted and everything else, because they realized if they didn't make that partition, they would just get themselves tangled in a gigantic mess. Because if you're their scale, it's actually really hard to delete things because they have so many backups of everything and tape drives and all the rest of it. So it's actually really hard. And from a legal perspective, if someone says, do you still have that record? If your answer is, I don't know, then that's not going to really hold up in a court of law. Absolutely. I think that this is going to be a very interesting type of pressure. I think what's likely to happen is it will create a commercial driver for brokers that simplify this. And so you'll end up with, you still need to be pretty big, but in a way it's kind of like the mega edge. You might get someone who becomes a kind of local broker. And I think that's a perfect role to investigate in New Zealand, where we've got this interesting mix of what is not likely to come to New Zealand by the way of high-scale computing. Well, of course, we are getting data centers from the big providers, but Amazon have already indicated they're not putting a complete availability region here. It's a kind of smaller availability region. It's like, okay, well, what's not coming? We'll find out when they actually finish it. So yeah, I think absolutely that will create an interesting transition. And I think there's different players that have different pressures in that space, but it will definitely be a rocky road for some, and they may end up settling with something like this broker solution or having to get to a scale where they actually just change what they do. I mean, the Dropbox one's an interesting one for me because that's an example where Dropbox were essentially an Amazon-driven thing for a long time, and then eventually they got to the scale where they crunched the numbers and went, actually now the cloud's not good value for us anymore. It is actually worth us going out and doing the OpEx and actually buying, sorry, CapEx, and actually that's my commerce knowledge coming through again. The CapEx is actually worth buying data centers in the different places because we're so big, that's actually going to be cheaper for us. And then also it means your legal teams can be spotted around the different places. That's an excellent question.
Question.
The interactions between malware and DDoS attacks and what was the other one? Data breaches. Yeah, that's a very good question. I think that in terms of the interactions there, I kind of tried to not give a clear answer on the security slide, saying that at one hand there are these like things that local does better, and on the other hand there are things that the cloud does better. When it comes to things like malware, the visibility that these organizations have is really very good. But as I said, the problem is that if you have something like heterogeneity, a problem can occur that's going to suddenly take out a very large number of services. And so you'd assume that the large threats, which are probably nation-scale players or particularly big criminal organizations or whatever, probably have their fingers poised over buttons that they know could take out chunks of infrastructure. We've seen failures that have been quite large scale that have happened in content delivery networks. So I mentioned those briefly. That's where you get a kind of caching layer that's pushed out from the cloud for data objects. In many cases, organizations' designs aren't resilient to the CDN failing. They should potentially be, because it should just go back to origin servers and still continue to work, but often it doesn't. And so we've seen a number of times recently where glitches on CDNs have actually taken out much more infrastructure than should have been taken out. The difficulty is how you kind of test this, because most organizations don't want your cloud provider to say, every third Sunday of the month, we're just going to like randomly fail and let's see what your software does. It is what Yahoo do. They've decided that if they want to stand, oh sorry, not to their customers, but Yahoo internally, they wanted to know that their resilience measures actually work. So they actually do a test run. I don't know who gets to pull the switch, but someone gets to essentially yank the power supply out from one of their data centers and they just check that everything continues to work. Because everything's supposed to continue to work. But I mean, as you probably often hear, people discover the blank backup tapes that don't have any data on them, and that's only discovered after the failure occurs. So definitely some organizations are moving forward to
university does something like that as well.
blank tapes. Oh, it does do something like that. Yeah, okay, cool.
That's at the beginning of a semester.
I guess one thing it does though is it kind of shifts the accountability for those sorts of issues. So
Absolutely.
when you get larger organisations,
Yes.
then the smaller organisations are able to offload their risk and make the larger, more specialised organisations responsible for those.
Absolutely. But the commercial responsibility stuff then leaves my technically minded understanding. Because, I mean, if you look at, so with the cloud paper that I run down as an undergrad paper, third year paper, looking at the cloud law that we examined, if you look at the terms of service of, is that my time up? Totally up. If you look at the terms of service of most cloud providers, and they might have all changed, I haven't checked like last week, but I think I probably haven't. Most cloud providers' legal agreements say, effectively, we don't give you any guarantees. So like literally, if you uploaded your data and the next day they said, we deleted it all, you wouldn't have to sue them because you've actually signed up to a service contract that said, that's fine. And it's not even best effort.
And they say, well, our best effort, in our best effort, we say, 99% uptime,
Yep.
But it's not that they deliberately word it so that in terms of legal liability.
Legally, yeah, and we're in a weird position there. Like again, software engineering, as we know, software licensing, I'm not going to blame software engineers, software licensing is odd, like compared to what you'd expect in terms of handing over a completed civil engineering project, like a bridge, people will keep some responsibility for its functionality. You write software to control an autonomous car, it's not so clear. I mean, it's not clear that you end up being directly responsible for that. It's just not clear. And that's a situation which is likely to need to change. But I mean, as you know, from the way we write software at the moment, it's not an easy thing to shift at the moment. That will be very interesting times for the future. Yeah? Oh, okay. Yeah.
A lot of the Many of the large cloud providers, a small number of them, are in the advertising business.
Yes.
Advertising and other retail business. And so they're very interested in what you're doing, what you're looking at, where you're going, and so on. My question is, how much do you think that incentive is shaping the direction of IoT versus we want our systems to be secure and reliable?
That's a great question. So to say that the most big cloud providers are connected to advertising companies, like, is this a coincidence? Does that mean that we're going to have a similar pressure on Internet of Things with respect to being interested in people's data? Right now, we have the problem we've got no way to express the management of concerns about our data. So some people might be willing to sell some of their data if they knew how that worked, but that's not the agreement you go into with Facebook. I mean, it's just like, it's open show, you know. So this is a sort of difficult situation there. I think that will evolve. I'm not sure. I think that there's a sort of, I see it almost as being two levels, like the retail IoT devices. I suspect that you'll have your loyalty programs and stuff. That will be very strong. You know, that means that your fridge understands when your washing's done and figures out something useful about that and makes you a bagel or whatever. I don't think that's going to be going to me. I don't find myself so advertising connected there. But that's one level. I don't think that's the only place that we're going to go, because again, one of the standout players in this space, the ones that probably aren't so much advertising involved, IBM and Microsoft, are making very big pushes into we do it securely. And that's been like, that's a big sell for where they go. Actually, Google are doing a security sell as well, but they're also trying to kind of, no, they're not being evil anymore, are they? They stopped that. Anyway, whatever. The Google world is doing its own thing. But the Microsoft offerings, one of the things which has been interesting there is this idea of trusted computing. And so Intel, for example, developed their Secure Guard extension, CPU extensions. That's where you run encrypted software on the CPU. Unfortunately, you have to trust that Intel got the implementation right, and they've demonstrated a lot of mistakes recently, which might make you worried. But that kind of thing is appearing in some areas of the cloud, where the idea is that the cloud provider is trying to make it abundantly clear that they have no idea what you're doing. So they're actually trying to outsource the ability to do computing with no knowledge about the data, because they never see it decrypted. So homomorphic encryption and things like that can actually do useful computation on encrypted data. Those technologies exist, and they're starting to be really adopted as a sell for the security concerned companies. But for me, I see that as being two ends of a spectrum, probably that way, two ends of a spectrum. I think that I'm not sure there'll be an affinity on both sides. I think you'll end up with a lot of consumer data gathering and data mining in that space. That's one of my concerns for energy, by the way, is like the amount to which everything you do will be kind of, you know, fed into machine learning systems to optimize different retail patterns everywhere. And again, I just think we need to say, look, what is the net value to society of doing that, and what's the cost? And then that other infrastructure stuff, where I do think we'll get more of the trusted computing actually being a solid base that will be encrypted and protected. Again, it will be, you know, viable. It'll be liable to attacks, but it will be trying to have providers that really don't know anything about what you're offloading to them.
David, my question is around citizenship being national. And there's other ways that people are citizens, culturally. Apple, into a, you know, a range of brands. And so when we talk about sovereignty and ownership and decentralizing, what does that mean in a world where there's privatization and there's a struggle there, right? So
Yeah.
what does that mean from the design of the cloud and who I'm loyal to?
So I think, again, I'd split my answer between infrastructure that will just stay kind of broadly connected to geography and where undersea cables go and sort of infrastructure concerns like that, to concerns of that kind of affinity to commercial organizations. That will be a really interesting one to play out. I don't think I could pick where that's going to go by any means. I am aware that there is a tendency, and this is mostly just going to be a big disclaimer, there's a tendency for researchers perhaps of my age and my generation to assume that other generations may think the same way that I do about, you know, privacy, for example, and they may be completely wrong. Well, I know that generations think differently about privacy, so from that perspective, I would self-check what I believe would be what we should be trying to achieve in that space. But what I do think we miss at the moment is sensible user queryable accountability. And so this connects to, you're involved with the Veracity project. that theme is important here, this idea that you want to find out what is actually happening. You might not care, you might be actively enjoying that, but right now, most services provide you a way of taking out your data, and that's great. That's just like you kind of open a hose and this thing just plops a whole bunch of garbage in front of your feet. And it's like, okay, you've got the data we had on you, but of course you can't do anything with it because like you're not running their cloud service, so you can't really make a huge amount of sense of it. I mean, you might make sense of bits of it, but not very much. That's not a very sophisticated way of interacting with that kind of siloed existence. So irrespective of where people choose to go in terms of their affinities, I think we still need better technology to mean that you can query and check what the auditing and the trust relationships actually are, and that you play a part in that you choose to approve them. And again, my hope is that we get to a brokerage model in that space, where you might say, I want a particular type of filtering of my social media feeds. I'm not going to give that privilege to Facebook, but I'm going to have another organization that has a big enough scale of data processing to mean that I'm going to have my affinity be with that organization. It understands my values or whatever, and it forms this kind of network that can move that sort of job away from just being in one behind closed doors and one set of data centers to something where the process is more inspectable.
Is that role national?
Beg your pardon?
Is that a national role? Is that a governmental role?
Good question. I don't really know. I think we'll have to see the development.
Because efficiency is all very well, but it seems to me that you make things more efficient and people just want to use more of it.
Totally. Yeah, absolutely. Yeah.
So it seems a very open-ended thing. So my question is, in terms of the energy, where's the energy supply coming from? And is there going to be an interesting issue where the desire to move away from, say, coal means that something like the cloud is actually has some challenges in terms of maintaining its ability to serve?
Yeah, so this is a question relating to where the energy comes from, and there's a huge amount of energy that goes into cloud computing. Like, I mean, data centers take vast amounts of energy. Most of the big players, they have what's termed hyperscale data centers, which just means that, like the picture I showed previously, they're insanely large, and they're always sited next to renewable energy sources, blah, blah, blah. That's great, but the problem there is that there's two things that are problems with that. One is that you're not aware of all the other places that are using energy. So like the networking uses an amount of energy to get the data around, and the client devices, the things you use to actually access the cloud, take energy as well. But there's another question, which is, if you had that renewable energy there powering that data center, I mean, that's better than running it on coal, but is there an opportunity cost? Is it also next to something which is still running on coal because they can't run on renewables because all the renewables are going into the data center? That's where we really need to kind of think a bit more than just the individual pieces of that puzzle. And right now, I think we don't see that because there isn't really pricing that deals with renewability in the energy networks to the extent that we'd expect to see happen. And so I think that's going to be an evolution where you'll get more of a colored metric. I mean, people understand where energy plugs into the power network, but the point there, I think, is that the pricing doesn't take that into account quite yet, and that's what we're going to see more of. Data centers can shed a lot of load. So it's very likely that they can minimize their consumption if they've got a price signal to actually do that. But right now, I'm not aware of that happening for these sorts of really large-scale energy consumption areas. That's a whole different area of interest. There's a lot of development happening with price signaling to manage network demand, and cloud computing, because you can shift energy around, the computation will actually probably play quite a significant part in that. But at the same time, pumped hydro for us might be really good too.
Okay, so I think we'll leave it there. So
Okay.
thank you very much,
No
Dave,
worries.
once again.
Pleasure.
I'm sure if you have further questions, David will probably be quite
Yeah.
happy to
Oh,
answer,
absolutely.
So just pop on down.
We might turn off some mics first. I've got lots of mics. So, all good. It's true.